right, on this lesson, we are still talking about scale factor. We're talking about the scale factor, and I know you already watched the previous video, so you kind of understand how it works a little bit, but I've got the feeling that you don't understand as well as you need to. So we're going to go through several examples on this one. So for example, and you're going to notice this very first one here where it's a scale factor of 1/2. I'm going to come back and I'm going to do this one last. I believe that's the hardest one. So we're going to start with this one where the scale factor is 2. Notice that if we have an edge length here, which is just one edge length, and let's see if I can figure out how to highlight that, see if my computer is working well enough. All right, we'll use this nice red line. If my edge length from here to here measures that, and let's pretend that that edge length right there is 3, then when I go through a scale factor of twice as big, this edge would be 6. It's 2 times bigger, if that makes sense. So for the edge length, when you talk about scale factor, you're just talking about the scale factor. You're just timesing it by the scale factor. When you're talking about the face area, though, it's a little different. Now your face area is talking about the length times the width here, or these 2 dimensions right here. When you do that, you'll notice that this one here was a 3 times a 3, which is 9. Over here, however, this is going to be a 6 times a 6, which is going to be 36. So let me start putting in these numbers here, otherwise I'm going to get confused myself. This one here should be 9 because it's a 3 by 3, and I'll reposition that. And this one over here is going to be 36 in this area. You're going to notice, though, the scale factor is 2, but this number here is not 2 times bigger. In fact, this one is 4 times bigger, so it becomes, how did we get there? Well, the face area of this one becomes 2 to the 2nd power bigger. So this one here, put this back down in place here a little bit so we can see it a little better, is actually 2 to the 2nd power. Your scale factor is actually moved to exponentially bigger. And then, as we look at the third dimension within this, so when we take our third dimension, which is this little width right there, if this one here on the small shape is 3, and to find the volume of that, we go 3 times 3 times 3, so my volume of this whole cube right there is going to be 27. Hopefully that makes sense. Obviously by this point you should know what volume is and how to get that. So you got your volume of 27. But on the larger shape over here, what I've got is this side is 6 back here. So I'm going 6 times 6 times 6, which is 218. So I had to do that math real quick in my head. So the volume on this one is 218. If you remember right, the edge length was 2 times longer. It went from being a 3 to being a 6. The face area was 2 to the 2nd power times bigger, or 2 to the 2nd power is actually 4, so this is 4 times bigger. The volume on this one is not 4 times bigger, but it's 8 times bigger. Well, how do you get to the 8? Well, what that would be is 2 to the 3rd power. So you'll notice, I'm going to explain kind of why this happens again. When we're talking about the edge length, we're only talking about one dimension, so the exponent is to the 1st power. When we're talking about the face area, we're talking about the area of something. If you think about that, area is always so many units squared, and so it becomes the squared unit larger. And when you talk about volume, you're talking about cubic inches or cubic feet or cubic units larger. So we take the scale factor and we cube that for how much larger that is. Hopefully that makes sense to you. If that makes sense, here's what I want you to do, is I want you to take this video, pause it, and I want you to take the scale factor and find out what the scale factor, you don't need the sides, but just tell me what the scale factor for this one, for 3, and for the scale factor of 4, what those two would be. So pause the video. I'll be back here in just a couple seconds. By now, you should have done this answer. So edge length, what you should have gotten, and this should be easy, is 3. So if your scale factor is 3, your edge length will grow by 3. I'm trying to grab that 3 and move it up. I'm not having a very good time with that. There we go. Now, if that is 3, then my face area is going to grow by 3 squared. By the way, if you think about what is 3 squared, you're going to know that this is going to be 9 times bigger. So the edge length is 3 times bigger. The face area is going to be 9 times bigger. And then the volume is going to be 3 to the third power bigger. And again, 3 to the third power, a lot of people want to say that that equals 9 because they like to go 3 by 3, but that is not correct. In order to do that, you've got to go 3 to the third power, or 3 times 3 times 3, which is going to be 27 times bigger. So if the volume of this first cube here was 10, the volume of this one would be 270, would be 27 times bigger. Likewise, over for the scale factor for 4. Your scale factor is 4. That means that for the edge length, it's going to be 4 times bigger. There we go. So this is 4 times bigger. The face area, which measures the area, is going to be 4 excuse me, to the second power bigger. When we do that, 4 to the second power, anybody? 16, perfect. And finally, for the volume, it's going to be 4 to the what power bigger? 4 to the third power bigger. And by the way, if anyone knows what 4 to the third power is, that is going to equal 64 times bigger. So, if you think about that, if you had a cube here that was, again, let's go with 10. It's an easy number to multiply by. If the smaller one was 10, and the larger one is 4 times bigger, or the scale factor is 4 times bigger, all sides are 4 times bigger, the volume would be 640. Now, hopefully that all makes sense. So now we're going to go to the tougher one here. I said I'd come back to the scale factor, and this is one where the scale factor is 1/2. Here's what I want you to think about. The face area is going to be half as big times half as big. Remember, if we take 1/2 and we times that by 1/2, right now what should be playing through your mind is multiplying fractions is no problem. First that's right, it's in all of your heads now. You multiply the top and you multiply the bottom. So you would get the answer of 1/4. So hopefully that makes sense to you. So you had 1/2 times 1/2 to get the face area of this one to be 1/4 the size. Now if we're talking about volume, we're taking that to the third power, meaning we're going to take 1/2 times 1/2 times 1/2. Well, when you do that, the wrong answer would be to say 1/6. The correct answer would be to say it's 1/8. Because 2 times 2 is 4 times 2 is 8. So this cube, the smaller cube, is going to be 8 times smaller. So think about that. If the large cube here had a volume of 80 cubic units, the small one, which is 8 times smaller, is only going to have a cubic measurement of 8 cubic meters. So that's one way you can kind of go back and forth between those. Hopefully this makes good sense to you. If not, I'm sure you'll come in the morning or stay after school to get more clarification on this. Have a great day.